Welcome to Think Mastermind. Before watching this video, please subscribe and click on the bell button.
Hello students, welcome to Think Mastermind. Today we are going to find eigenvalues and eigenvector of non-repeated eigenvalues for symmetric matrix. So given matrix A is equal to symmetric matrix because the first row second element, that is 1, the first row second element is equal to second row first element. Similarly, first row third element is equal to third row first element, and second row third element is equal to third row second element. Therefore, the given matrix is symmetric matrix, and it also 3 by 3 matrix. So the characteristic equation of 3 by 3 matrix is lambda cube minus s1 lambda squared plus s2 lambda minus s3. Eigenvalue is, solving the characteristic equation, we can find the lambda value. So what is S1? S1 is sum of diagonal elements, that is A11 plus A22 plus A33, that is 1 plus 5 plus 1 is equal to 7. That is nothing but trace of A. Trace of A is sum of diagonal elements. S2, minor of main diagonal elements, that is the first minor of diagonal element is 1. Leave the corresponding column and row. Find the determinant value of remaining elements. Therefore 5 1 1 1 plus second diagonal element is 5. Leave the column and corresponding row. The determinant value of remaining element is 1 3 3 1. The third diagonal element is A33, that is 1. So leave the column, row. Determinant value of remaining element is 1 1 1 5, that is equal to, finding determinant of 2 by 2 matrix, cross multiplication, that is 5 into 1 minus 1 into 1. Therefore 5 minus 1 plus 1 minus 9 plus 5 minus 1, that is equal to 4 minus 8 plus 4, that is equal to 0. S3, determinant of A, that is equal to 1, that is the first element. Leave the corresponding row and corresponding column. Then determinant value of 5 1 1 1 minus 1 into the determinant value of remaining element is 1 3 1 1. Similarly, in first row third element is 3 plus 3 into determinant value of, leave the column and corresponding row, determinant value of 1 5 3 1, that is equal to 1 into 5 minus 1 minus 1 into 1 minus 3 plus 3 into 1 minus 15, that is equal to 4 minus 1 into 1 minus 3 is minus 2, minus 2 into minus 1 plus 2 plus 3 into minus 14, that is equal to 6 minus 42, that is equal to minus 36. Therefore, characteristic equation is lambda cube minus 7 lambda square plus 0 lambda minus of minus 36 plus 36, and eigenvalue is lambda cube minus 7 lambda square plus 36 is equal to 0. Eigenvalue obtained by trial and error method. If lambda is equal to 1, 1 cube minus 7 into 1 square plus 36, not equal to 0. Therefore, lambda is equal to 1 is not a root. If lambda is equal to minus 1 the whole cube minus 7 times of minus 1 whole squared plus 36, which is not equal to 0. And lambda is equal to 2, that is 2 whole cube minus 7 into 2 whole square plus 36, which is equal to 8 minus 28 plus 36, which is not equal to 0. If lambda is equal to minus 2, that is minus 2 whole cube minus 7 into minus 2 whole square minus 36, that is equal to minus 8 minus 28 plus 36, it is equal to 0. Therefore, one of the root is lambda is equal to minus 2 and the remaining root found by synthetic division method. The coefficient of lambda is lambda cube coefficient is 1, lambda squared coefficient is minus 7 and lambda coefficient is 0 and constant term is plus 36. So lambda is equal to minus 2 is one of the root. So here we have to put 0. Adding 1 plus 0, that is 1. 1 into minus 2, that is minus 2. Adding that, we're getting minus 9. Minus 2 into minus 9 is plus 18. 18 plus 0 is 18 and 18 into minus 2 is minus 36. So adding 36 and minus 36, value is 0. Now the cubic equation is reduced to quadratic equation considering coefficient of lambda squared is 1, lambda is minus 9 and constant term 18. Therefore, the quadratic equation becomes lambda squared minus 9 lambda plus 18 equal to 0. This is quadratic equation in lambda. Solving the quadratic equation, product is plus 18 and sum is minus 9, that is minus 6 into minus 3 is a factor. Therefore, the factor of quadratic equation is lambda minus 6 into lambda minus 3, that is equal to 0. That is lambda is equal to 6, lambda is equal to 3. Therefore, eigenvalue of given matrix is lambda is equal to minus 2, lambda is equal to 3, lambda is equal to 6. Eigenvector is A minus lambda I into x is equal to 0. Capital X is column matrix x1, x2, x3. If lambda is equal to minus 2, A minus of minus 2 into I into x1 corresponding eigenvector of lambda is equal to minus 2 such that the matrix diagonal element subtracted by minus 2, that is minus into minus plus, that implies the diagonal element in A plus 2i into x1 is equal to 0. Therefore, 1 plus 2, 1, 3, 1, 5 plus 2, 1, 3, 1, 1 plus 2 into eigenvector x1, x2, x3 is equal to 0. So that implies 3, 1, 3, 1, 7, 1, 3, 1, 3. From this it is clear that the first row and third row are same. So we have to find x1, x2, x3 value. We are taking either second and third row or second and first row. So here I am considering second and third row. X1 value is determinant of these numbers, that is 7, 1, 1, 3 is equal to minus x2, that is leave the x2 coefficient 7 and 1 and determinant of 1, 1, 3, 3. is equal to x3 divided by determinant of 1, 7, 3, 1. That is x1 by 7 3s are 21 minus 1 is equal to minus x2 by 1 into 3 3, 3 minus 1 into 3 3, 3, that is x3 divided by cross multiply, that is determinant of 2 by 2 matrix 1 minus 21. So that implies x1 by 20 is equal to x2 by 0 is equal to x3 by minus 20. Therefore, the eigenvector corresponding to eigenvalue lambda is equal to minus 2, eigenvector x1 is 20, 0, minus 20. So that is equal to 1, 0, minus 1. Next, if lambda is equal to 3, corresponding eigenvector is x3 such that a minus lambda 3, lambda value is 3 into I, x2 is equal to 0. x2 is corresponding eigenvector of lambda is equal to 3. Therefore, diagonal elements in a matrix subtracted by 3, that is 1 minus 3, 1, 3, 1, 5 minus 3, 1, 3, 1, 1 minus 3 into x2 vector is x1, x2, x3 is equal to 0. That implies 1 minus 3 is minus 2, 1, 3, 1, 2, 1, 3, 1, minus 2 into x1, x2, x3 is equal to 0. Now we are going to find x1. 3 rows are different, so we take any 2 rows. So here I am taking first and second. Therefore, the x1 value is, this first column represent x1 coefficient and second column represent x2 coefficient and third column represent x3 coefficient. Therefore, x1 is, leave the first x1 coefficient, the determinant value of 1, 3, 2, 1 minus x2, determinant value of minus 2, 3, 1, 1, x3 is minus 2, 1, 1, 2. Therefore, x1 is 1 minus 6 is equal to minus x2 is minus 2 minus 3 is equal to x3 is minus 4 minus 1. Therefore, x1 divided by minus 5, x2 divided by 5, x3 divided by minus 5. Therefore, x2 is equal to minus 5, 5, minus 5, that is equal to minus 1, 1, minus 1 when lambda is equal to 3. Next case, if lambda is equal to 6, the corresponding eigenvector is x3, therefore minus 6i into x3, a minus 6i into x3 is equal to 0, where x3 is column vector. Therefore, the matrix becomes 1 minus 6, 1, 3, 1, 5 minus 6, 1, 3, 1, 1 minus 6 into x3 is x1, x2, x3 equal to 0. That is minus 5, 1, 3, 1, minus 1, 1, 3, 1, minus 5 into x1, x2, x3. Similar way, 3 rows are different. We can choose any 2 rows. Here I am choosing second and third. x1, determinant of -1, 1, 1, -5 is equal to minus x2, 1, 1, 3, -5. x3 is determinant value of 1, -1, 3, 1. Therefore, x1 is 5 minus 1, minus x2 is -5 minus 3, that is -8. x3 is 1 minus of -3, that is 4. So therefore x1 is 4, x2 is 8 and x3 is 4. That implies the corresponding eigenvector for lambda is equal to 6. x3 is 4, 8, 4, that is equal to 1, 2, 1. Thank you, student.
Hope this video is useful for you. Please subscribe and click on the bell button.